We are in part 4D, final section here, and we are solving equations not by factoring now, but using the quadratic formula. Now, the quadratic formula is not something I would ever expect you to memorize, but some of you might do that just out of habit of using it. The way it goes is you take negative b plus or minus b squared minus 4ac all over 2 times a. Now you might be thinking, who thought of that one on a sunny afternoon? Not I. But the way, if you ever were to try to isolate x in this problem by trying to complete the square, that's another technique for solving quadratics that we're not going to use this unit. You try to solve for x alone and factor it out of that problem, you will end up every single time ending up with this basic format. So this is really just a shortcut to that. Nice thing about it is, even though it's kind of a complicated formula, you don't have to spend a bunch of time looking for numbers factoring and do three-step factoring. Once you get your numbers, you can plug them into this and it will work every single time to tell you your two solutions. So let's go ahead and give it a try. We're going to work with some of the problems near the bottom here, number 5 and number 6. So let's bring our quadratic formula down with us. And on the first one, number 5, you'll notice that just like with factoring, sometimes you have things on the other side of the equation. You need to get everything isolated on one side before you start using this quadratic equation. Most important thing, if you don't have a 0 here, you're going to run into trouble. So let's do that. Let's add 4x to both sides. And we're going to keep our 3x squared. We're now going to have plus 4x, so that's going to make this only negative 11x, and then plus 6, and it's going to equal 0. Now that we got our 0, put a little happy face in there to remind us that that's the most important step in this whole process. Now we need to plug in our a, our b, and our c. So a, b, c. And don't forget that negative. So the first part starts out with negative b. So I take negative 11 plus or minus, which means we have two solutions possible here, the square root of b squared, so negative 11 squared, minus 4 times a, which is 3, times c, which is 6. It's all under the root, and all of that gets divided by 2 times a, which is 3. What I always like to do is simplify that part under the root right away and then cancel out my double negative. So I have an 11 out here. I know I have a 6 on the bottom, 2 times 3. And then under my root, I have 121. So negative 11 squared is a positive 121. I thought it was going to be a positive number. Minus 4 times 3, which is 12. Times 6, which is 72. So 121 minus a 72 is going to be 49. So plus or minus the square root of 49. Now, I know what the square root of 49 is. I know that that's 7. Sometimes it comes out nice and cleanly like that. So plus or minus 7 all over 6. Whenever you get nice, clean, whole numbers, you probably don't want to leave this as your final form, as your final answer. I would say you always want to turn those into numbers, because sometimes they'll simplify into clean numbers, sometimes they'll still be kind of nasty fractions. So let's try this. We take the plus one first, so we do 11 plus 7, which is 18, over 6. So 18 over 6 is one of our solutions. And I look at 18 over 6, I can divide top and bottom by 6, leaving me with 3 over 1. So my one solution is 3. How nice. Now my other one, I look at the minus. So I go 11 minus 3, and that's 4 over 6 again. 4 over 6, I can divide both of them by 2, so I get 2/3. So my two solutions are x equals 3 and x equals 2/3. Those are my two possible solutions. So let's move on to our next problem. We have number 6 here. Again, we have stuff on the wrong side of the equation. We don't like that, so let's get that all over to the same side. To do that, I need to add 8x squared to both sides to make this one go away. And when I do that, I get 8x squared plus 1x squared, so 8 plus 1, they're like terms, they add up to 9x squared. Then I have negative 5x, but I'm adding 5x to both sides, so plus 5x onto the negative 9. Negative 9 plus 5 is negative 4x. And then plus 1 equals 0. So that got added over, that got added over, left with 0 on that side. So now this is the problem I work with, which means that I have an A, B, and a C. And when I want to plug this in, I go negative, let's get our formula back up on the screen, negative 4, so negative b, plus or minus the square root of b, which is negative 4 squared, minus 4 times a, which is 9, times c, which is 1, all over 2a, which would be 2 times 9. Again, I want to clean up my under the root part here. I see that I have negative 4 squared, which is 16, positive 16, minus 4 times 9 is 36, times 1 is just 36, and that's going to be negative 20. So when I rewrite this, I have a positive 4, double negatives cancel, plus or minus the square root of negative 20 all over 18. Now, this looks pretty okay, unless you notice this one glaring flaw with the problem, which is I'm trying to take the square root of a negative number. And it doesn't matter how I do this, the fact that the negative is underneath the square root means it's not going to work. If the negative were out front, that would be a totally different story. If I had a negative right here, which I actually do because of that plus or minus, that's not a problem. It's the negative inside the square root that is an issue. If you take out your calculator and try to take the square root of negative 20, it's going to give you an error. It's going to say it's impossible to take the square root of a negative number. So we're done. Just cross it out and put no solution. Every so often you come across a lucky problem like that, where you have no solution. Where you have the square root of a negative, it's going to be as if the parabola looked something like this. If you were to graph this, it might look something like this, where it never crosses that x-axis.